Welcome to Teju's Academy. Please subscribe our channel.
Acids, bases, and salts. Acids are those substances which release hydrogen ions when dissolved in the water. So acids are substances which release hydrogen ions H plus when dissolved in the water. Then hydrogen ions cannot exist alone. Hydrogen ions combine with the water molecule and to form H3O plus ions. Okay. So when acids are dissolved in the water, it will dissociate into its corresponding ions. Suppose when you dissolve HCl in water, so what it will give when you dissolve HCl in water? So this HCl dissociated into H plus and Cl minus ions. This HCl dissociated into H plus and Cl minus ion. So when you dissolve this HCl in water, it will give H plus ions and Cl minus ion. Suppose you are not adding the water, there is no dissociation in HCl. Okay, so when the dissociation will takes place, when you add the water, in that time only dissociation takes place. Okay, then HCl dissociated into H plus and Cl minus ions. Okay, these H plus ions are cannot exist alone. These are the unstable. Okay, these H plus ions they combine with the water molecules and form as H3O plus ions. Okay, so hydrogen ions combine with the water molecule H2O to form H3O plus ions, right? Then what is the definition of the basic definition of the acid? Acids are those substances which releases hydrogen ions when dissolved in the water. Okay, so when you are not dissolving the water, so acid as itself they won't give the H plus ion, they won't release H plus ions. So when they will give the H plus ions, when you dissolve the HCl in the water, then only it will give the H plus ions. Okay, and these H plus ions cannot exist alone. And these H plus ions combine with the water molecule and will give hydronium ions. Okay, H3O plus ions will come here. So what are the ions you will get here? When you dissolve the acids in the water, H3O plus ions you will get. Right. What is the main definition of the bases? Bases are those substances which release hydroxyl ions when dissolved in the water. Okay. So when you dissolve in the water, bases releases OH minus ions. The substances which releases OH minus ions is called as bases. Okay, so when these bases are dissolved in the water, then only you will get the OH minus ion. If you are not dissolving in the water, means bases as itself they won't give the H, as itself they won't releases the OH minus ions. Okay, when it will give the OH minus ions, when you dissolve in the water, then only it will give the OH minus ions. Okay, so bases which are soluble in the water we call as alkalis. Alkalis means the bases which are soluble in the water, and the bases we called as alkalis. Example for alkalis is sodium hydroxide and calcium hydroxide, and these alkalis are soluble in the water. They can soluble in water. Some of the bases they won't soluble in the water. That won't be called as alkalis. So the alkalis means which soluble in the water. The bases which soluble in the water, and that bases we called as alkalis. Okay, now going to the next slide. Now you see here I am dissolving H plus ions and Cl minus ions. So HCl. HCl when you are dissolving the water, what it will give? It will give H plus ions and Cl minus ions. Okay. So similarly, when you dissolve the potassium hydroxide, it will give K plus ions and OH minus ions. Okay, the substances which release OH minus ion in water is called as bases. The substances which release H plus ions in water is called as acid. Move on to the next slide. So properties of the acids or bases and bases. So what are the properties of the acids and bases? What is the taste of the acid here? Yes, what is the taste of the acid? Acids are sour in taste, right? Acids are sour in taste, and bases are bitter in taste. Bases are bitter in taste. So when you dissolve in the water, they dissociated into ions. These ions allow the electricity through it. That means when you dissolve the acid in the water, or when you dissolve in the acid in the water, they conduct electricity. Okay. So when it will conduct electricity, when you dissolve in the water. When you dissolve in the water, what will happen? This acid dissociated into H plus and Cl minus ions. These H plus and Cl minus ions carries electric current. Okay, it conducts electricity when you dissolve in the water. And all of you remember this, when you put blue litmus, this acid turns the blue color litmus to the red color. Then acid turns blue litmus to red litmus. So when you dip the blue litmus paper in the acid, then that color of the blue litmus paper changes into the red. Similarly, when you dip the bases in water, Similarly, you dip the red litmus in the water, so which consists base. Okay, that red litmus converted into blue color. Okay, so acid changes blue litmus to the red, bases changes red litmus to the blue. Okay, so when will you say our acid is the diluted? When will you say our acid is diluted? When will you say our acid is diluted base? When it is mixed with more amount of water, then we can say that that acid is diluted. Suppose there is no water ions, there is less number of water ions, there is less number of hydronium ions, there is less number of water molecules, there is more number of H plus ions, means that is concentrated acid. Okay, compared to water, there is more number of OH minus, means that is concentrated base. When you dissolve the water, when you add the water to the acid or base, what will happen? At particular unit volume, there is a decrease in the H plus ions will take place. Okay, so when you add the water to the acid, what will happen? The acid dissociated into H plus and Cl minus. You are adding more water, right? If you are adding more water, then what will happen? In unit volume, there is a decrease in the number of H plus ions. Okay, there is if there is decrease in the number of H plus ion per unit volume, this results in the formation of the dilute acids. When will you get the dilute base? Here you are taking base, you are adding so much water. First you are add 1 liter of water and you 2 liter, you will dilute like that. You are adding infinity of water. If you are adding more amount of water in particular space or in particular volume, what will happen? OH minus ion concentration will be decreases, results in the formation of the dilute bases. So which results in the formation of the dilute bases? When you add when you add water to the acid or water to the base, what will happen? So now we have to add here. How will you add the? Sorry. Please cut in the questions. Reading. Dilute acids and dilute bases. Dilute acid means when you add acid to the water slowly, or acid to the water or water to the acid. Do not add water to the acid. So add water, you take water in beaker, excess amount of water you take little amount of acid in the dropper, add little drop wise, you add the water to the acid. So then it will give some exothermic reaction. So how it is giving the temperature? When you add the acid to the water, when you touch the beaker, we can feel that hot. The beaker is become hot. That means the dilution of acid or dilution of bases or exothermic reaction. So when you add water to the acid or when you add water to the base, what will happen? Temperature will release. Temperature increases. Means that is exothermic reaction. So the reactions in which heat is released we call as exothermic reaction. The dilution of acid and dilution of base is an example for exothermic reaction. Okay, now you see, yeah, which one we called as strong acid and which one we called as strong base. Which will give more number of H plus ions in aqueous solution, that one we called as HCl, strong acid. Okay, strong acid means when you dissolve in the water, it will give 100% dissociation takes place. The substance in which 100% dissociation takes place when you dissolve in the water, So that will give more number of H plus ions. Okay, so that acid we called as strong acid. The acid which releases less number of H plus ions, and that acid we called as acetic acid. So example for the weak acid is acetic acid. Example for the strong acid is HCl. Okay. Now you take your strong base. So what is mean by strong base? What is mean by strong acid which releases more number of H plus ion, that is called as strong acid, which releases less number of H plus ion, that we called as a weak acid. Example for the strong acid is HCl, HNO3, H2SO4. And example for the weak acid is acetic acid, all carbon hydrogen related compounds, right? Acetic acid, carboxylic acids, carbonic acids, these are all comes under weak acid. Okay, so in this case 100% dissociation not takes place, only partial dissociation only takes place in the case of weak acids. That means it gives less number of H plus ions, right? So when you take strong base, when you dissolve the this strong base, when you dissolve in the water, it gives more number of OH minus ions. Okay, and weak base means it releases less number of OH minus ions. Example for the strong base is sodium hydroxide. Okay, sodium hydroxide, all first alkali group hydroxides we call as the strong oxides. You take when you take a sodium hydroxide, right? Stored sodium hydroxide. Uh, so you tell your first group alkali metals: lithium, sodium, potassium, rubidium. Okay, potassium hydroxide, sodium hydroxide, potassium hydroxide, and secondary group element hydroxides also, magnesium hydroxide. Okay. Next, second group consists beryllium, magnesium, calcium hydroxide. Okay. First A group hydroxides and second A group element hydroxides are the strong bases. The remaining bases are weak bases. Okay. Weak base means which releases less number of OH minus. So which releases less number of OH minus, that we called as weak base. Okay. When it will release less number of OH minus, when you dissolve in the water. Okay. Without adding the water, there is no dissociation. Okay. Right. So weak bases releases only less number of OH minus ions. Example for the weak bases is ammonium hydroxide, that is NH4OH. Right. Now, what are the common acids? So these are we can use in daily use, right? So vinegar means acetic acid. In tomato, oxalic acid is present. In orange, citric acid is present. Lemon also. In lemon, citric acid is present. In tamarind, tartaric acid is present. In curd, lactic acid is present. These are the common acids. Already we know this, all these things. Already we tasted also this. Okay. So vinegar is acidic. Vinegar means that is acetic acid. Acetic acid formula is CH3COOH, right? So which is present in vinegar. Tomato. In tomato, it consists oxalic acid. Oxalic acid means COOH. Okay, this is oxalic acid. So orange and lemon consists citric acid. Tamarind consists tartaric acid. Curd consists lactic acid. Okay. Now here we have the indicators, types of indicators. Yeah, the substances that tells us whether a substance is acidic or basic by changing color or smell, etc. We call as the indicators. Suppose you take acid. Suppose you take acid. Then how will you know that is acid or base? You take acid or base, right? So if you use olfactory to identify this, is it acid or base, we have some indicators. Okay, by adding that indicators, we came to know that so which one is acid and which one is base by color change, or by smell change, or when you add this, cut it. Substance that tells us whether a substance is acidic or basic by change in color, smell, etc. We called as indicators. Indicator means it is in the solution form, or some indicators are paper in form. Some natural indicators also exist. Turmeric also not natural indicator. Litmus also natural indicator. Okay. So when you add acid to the turmeric, there is no change in the color. Okay. When you add this turmeric to the base, the turmeric color changes to yellow to reddish. Okay. So by this color change, we can came to know the acid will not give any color with the turmeric. The turmeric color remains same. Okay. When you add this turmeric to the base, it will give reddish in color. Okay. Now, olfactory indicators. Olfactory indicators means in the types of indicator, first we have first one olfactory indicators, and second one natural indicators, and third one synthetic indicators. Substance that changes its odor in acidic or basic medium we call as a olfactory indicator. Suppose yeah, olfactory indicators. Example for the olfactory indicator is onion. Okay, so onion will give smell in acidic medium and it will not give smell in basic medium, right? So natural indicators you take turmeric or litmus we can obtain from the lichen, right? So turmeric, when turmeric react with the acid, it will not give any color change. It remains same. That will give only yellow color only. The color of the turmeric will not change when you add acid to the turmeric. Okay, so when you add turmeric to the base, the turmeric color changes to reddish color. Okay. Now here we have the synthetic indicators. What are the synthetic indicators? We have methyl orange and phenolphthalein. We call it as the synthetic indicators. Methyl orange, which is in reddish orange color. When you add acid, it will give red color. When you add base to this, the methyl orange color changes to yellowish color. Okay. Phenolphthalein will not give color in acidic medium, and phenolphthalein color changes to pink in basic medium. In basic medium, phenolphthalein will give pink color, and acidic medium there is no color change, and there is no color in acidic medium. Okay. Next one, here indicators. So what is the natural color of red litmus, which is in the red color? Okay. So this red color red litmus paper, when you dip in the acid, there is no change in the color. It remains red only. So when you dip in basic medium, the red color paper turns into the blue color. Okay. Basis changes red litmus paper to the blue. Okay. So when you take blue litmus, the color of the blue litmus paper is blue only. When you dip this blue litmus in the acid, it will give red color, means it turns the red. Okay. When you dip in the bases, the color of the blue litmus don't change. The color of the litmus paper remains same. Means here acids changes blue litmus to red, bases changes red litmus to blue. Okay. Next, phenolphthalein. Phenolphthalein, natural color of the phenolphthalein is colorless. When you add this phenolphthalein acidic medium, there is no change in the color. So when you add this phenolphthalein in the basic medium, the color of the bases changes to pink color. Similarly, here methyl orange you take. Natural color of the methyl orange is reddish orange color. So this methyl orange, when you add in the acidic medium, it will give the red color. This methyl orange, when you add to the basic medium, it will give the yellow color. Next one. So you see this is the blue litmus paper, right? The blue litmus paper is changes to the red when you dipped in the acidic medium. So litmus paper turns red when it is dipped in the acidic solution. Now you is taking red litmus paper. So red litmus paper, when you dip in the basic medium, the color of the red litmus paper changes into blue. Means the litmus paper turns blue when dipped in alkaline solution. Litmus paper turns red when dipped in acidic medium. Okay. Now you see, these are the some reactions, chemical properties of acids. When acids react with the metal, it releases hydrogen gases. So you take acid HCl, when it is react with the zinc, so it combines a zinc chloride and releases hydrogen gases. Okay, when acid is added to the metal, what will happen? Some of the fumes will come out from that. Okay, during that reaction. So what will form? It will give only hydrogen gas and it forms salt. What is that salt we got here? Zinc chloride. When you add HCl to the zinc, what we are getting? Here we are getting zinc chloride, ZnCl2, and it releases hydrogen gas. Now, when acid is react with metal carbonate, so HCl you take. HCl when it is react with the Na2CO3. So in sodium carbonate, there is a carbon dioxide is there. When you heat the sodium carbonate, it releases carbon dioxide. Okay. When it is react with the acid, some of the fumes will come out from that reaction. That fumes is due to releases of carbon dioxide gas. Okay, here it will give carbon dioxide gas and water, and it will form sodium chloride salt. When acid is react with the metal carbonate, it will give salt, carbon dioxide and water. Similarly, When acid react with the metal hydrogen carbonate also, here also we are getting the same thing. Here also we are getting salt, CO2 and water. Okay. When HCl react with the sodium bicarbonate, it also gives sodium chloride, CO2 and water. When acid react with the metal oxides, okay, metal oxides are in basic in nature. So the basic in nature, so metal oxides are in basic in nature means it will react with the acid and it will give salt and water. Okay, suppose one more I'm revising this, rewinding. So acid plus metal, when acid is react with the metal, it will give salt and hydrogen gas. Suppose you take one metal strip, iron or anything. So some 2 or 3 drops you take HCl gas and you pour the HCl drops on the metal sheet. Then you can observe some of the fumes will get evolved from that metal paper. So it indicates that there is a evolution of the hydrogen gas happening. Okay, when metal react with any acid, it releases hydrogen gas and they will form their corresponding salts. When HCl is reactive with the zinc, it will give zinc chloride. When H2SO4 react with the zinc, it will give the zinc sulfate. When HNO3 is reactive with the zinc, it will give the zinc nitrate. Means that they are giving their corresponding salts. When HCl is adding to the zinc, it will give zinc chloride. When H2SO4, when added to the zinc, it will give zinc sulfate. Sulfuric acid will give zinc sulfate with the zinc metal, right? When you add HNO3 to the zinc, HNO3, NO3 is there. So if this NO3 is react with the zinc and it will give zinc nitrate. Okay. In all reaction, in all these steps, hydrogen gas will be evolved. Always remember when acid react with the metal, there is a release of the hydrogen gas takes place. Okay. Uh, some salt also there, it will give their corresponding salts also. Next one, when acid react with metal carbonate, and this metal carbonate here we are taking the sodium carbonate. This sodium carbonate we called as the washing soda also, right? When this acid react with the sodium carbonate, what it will give? It will release CO2 gas. Okay, and also it will form sodium chloride and H2O, salt, water, and gas. So what is the gas we are getting here during this reaction? Carbon dioxide gas we are getting. When acid is reacting with base, like so metal carbonate is having the basic in nature, right? So here we are taking the sodium carbonate. The sodium carbonate, yeah, the sodium carbonate which is in basic in nature. So that's why it is reacting with the acid. Okay, the substance which is in basic in nature that will react with the acid and will give salt and water, right? So here one more product also formed, that is CO2. Here CO2 gas is evolved during this reaction. Suppose you take HCl, when you add sodium carbonate Na2CO3, what it will give? It will give sodium chloride and CO2 and water. Similarly, you take one more reaction. So when HCl in the place of HCl you take H2SO4. Then when you take H2SO4, what it will give? H2SO4 will react with sodium carbonate. What it will give? It will give, first it will release CO2, right? CO2 water is the common for all, right? And also it will form Na2SO4. Okay, so equation is balanced or not? Yes, it is balanced. Okay, so H2SO4 plus sodium carbonate, what it will give? It will give sodium sulfate. Okay, this sodium and sulfate will combine, it will give Na2SO4 and CO2 and water. Clear? Similarly, you take any metal carbonate, you take calcium carbonate, metal carbonate also, calcium carbonate also, metal carbonate. When calcium carbonate react with the acid, what it will give? You see here, when calcium carbonate, when react with acid, what it will give? It will give calcium chloride, CaCl2, and it releases CO2 gas and also it will form water. So to balance this equation, you put 2 here, 2HCl plus calcium carbonate and it will give calcium chloride, CO2 plus water. And this reaction you carry with sulfuric acid or nitric acid also. When you take nitric acid, what it will give? In the place of H2SO4, I am replacing. In the place of HCl, I am replacing HNO3. When this HNO3 react with the calcium carbonate, so what is the salt you will get here? you will get here calcium nitrate. You will get calcium nitrate CaNO3 taken twice. Okay, why? Because so while writing the equation, you write formulas as it is. Don't change the formulas composition. So calcium valency is +2, nitrate valency is -1, means calcium is having the 2 valency, nitrate valency is 1. So when you change this, you will get CaNO3 taken twice. Okay, in this manner you have to write the formulas, right? HNO3 when react with the calcium carbonate, it will give calcium nitrate plus CO2 plus water. Now, similarly, when acid reacts with the metal hydrogen carbonate, here we are taking the sodium bicarbonate. This sodium bicarbonate we call as also baking soda, right? When this baking soda react with the acid, so what will you get here? You see here, this is a HCl. When it is react with the sodium bicarbonate, it also gives same thing. What are the things you are getting when react with the metal carbonate? Here also you are getting the same thing, right? When HCl react with the sodium carbonate, what it will give? It will give sodium chloride and CO2 gas and H2O. It will give CO2 and H2O, right? The same thing you can change the reactants. You in the place of HCl you take HNO3 or H2SO4. Anything you take H2SO4, right? When H2SO4 react with the sodium bicarbonate, what it will give? It will give Na2SO4. Why? Because here we are taking the sulfate. Here we are getting the sulfate salts, right? Na2SO4, and it releases CO2 gas, and also it will form water, right? When H2SO4 react with sodium bicarbonate, it will give sodium sulfate, carbon dioxide, and water. Similarly, in the place of sodium bicarbonate, you can take any other bicarbonates. You take calcium bicarbonate, magnesium bicarbonate, and carry over the same reaction. You will get the same things again. Suppose I am taking here HNO3. When HNO3 react with the magnesium bicarbonate, then what it will give? It will give salt. What is the salt you will get here? Magnesium nitrate. Magnesium valence is 2, nitrate valence is 1. So you will get magnesium nitrate NO3 taken twice. Plus also here we are getting here CO2 salt. CO2 gas. It releases CO2 gas and it will give H2O. When acid react with any metal hydrogen carbonate, it will give sodium chloride, CO2 gas, and it releases CO2 gas and it will form H2O. Next, when acid react with the metal oxide, what it will give? Acid react with the metal oxide. Metal oxide is basic in nature. Metal oxide is in basic in nature. When any acid substance, when it is react with the any substance which are in the basic in nature, it will give salt and water. That is a common for all. Okay, when acid react with the basic nature substance, it will give salt and water only. Here sodium carbonate also basic in nature, sodium bicarbonate also basic in nature, calcium oxide also basic in nature. So calcium oxide, why we are calling metal oxide? It has the oxygen is there. Metal with oxygen called metal oxide. When HCl react with the calcium oxide, it will give calcium chloride plus H2O, right? It will give calcium chloride and H2O. Then write some more reactions regarding metal oxides. You take in the place of HCl, you take H2SO4 and see the reaction, what is happening here. So you take H2SO4. When H2SO4 react with the calcium oxide, it will give its corresponding salt, that is calcium sulfate it will give. Okay. So, and also it releases some water. It will give some water. Now see, is it balanced or not? Yes, it is balanced. H2SO4 when react with the calcium oxide, it will give calcium sulfate and water. Here same thing here also happens. When HNO3 react with, you take metal oxide. In case of metal oxide, you can take magnesium oxide also. Okay. When HNO3 when react with the magnesium oxide, what it will give? It will give magnesium nitrate, MgNO3 taken twice plus H2O. Now you give here 2. Now it is balanced. HNO3 when react with the magnesium oxide, it will give magnesium nitrate plus H2O. Clear? Let's move on to the next slide. Yeah, these are the some important reactions of bases. Then here also base and acid. Bases are acids. When react with the metal, it releases hydrogen gas and it form corresponding salts. Here when base react with zinc, what are the products you will get here? What are the products you will get? You will get your sodium zincate, Na2Zn O2. This we call as a sodium zincate. This is salt, and also it releases some hydrogen gases. During this reaction, hydrogen gas is evolved. Okay, hydrogen gas is evolved. Here, same thing is happening when metal reacts with the acid. It will also give hydrogen gas. When base also react with the metal, it also releases hydrogen gas. In both cases, we are getting the same thing, that is hydrogen gas. Acid or base, whatever it may be, when it is react with the any metal, it releases hydrogen gas and also it forms their corresponding salts. When sodium hydroxide react with the zinc metal, so it will give sodium zincate and also it releases hydrogen gas. Now you see, when base here non-metallic, when bases react with the non-metallic oxides, so non-metallic oxides are in acidic in nature. When base react with acidic in nature having substances, that also give salt and water. When acid base, it will give salt water. When acid react with basic nature of substance, it also gives salt and water. When base react with acidic nature in substance, that also gives salt and water. You see here, when calcium hydroxide react with carbon dioxide is a non-metallic oxide and it releases calcium carbonate and water. So it will give calcium carbonate salt and also it will form water. Okay, now move on to the next one. You see here, just a minute. Yeah, some of the neutralization reactions here. Neutralization reaction means we are neutralizing the acidic nature, basic nature with adding both, right? When acid react with the base to each other, it produces salt and water, right? So during this reaction, what are the things you are getting? Salt and water we are getting. So you are taking HCl here, you are taking your base. When HCl is added to the base, what will you get here? Salt and water. Okay. Suppose you take one more here. When you take H2SO4, you take any other base. Give one example for the base. You take calcium hydroxide, magnesium hydroxide, potassium hydroxide, anything you take. So I am taking here magnesium hydroxide. So when acid, this is a strong acid, when react with the strong base, it will give salt and water. So what is the salt you are getting here? Here we are getting magnesium sulfate salt, MgSO4. Both are having the 2,2 valence. It means we will get here magnesium sulfate, MgSO4 formula. Formula of magnesium sulfate is MgSO4. And also you will get here H2O. Okay, to balance the hydrogens, to keep here 2. Front of H2O you keep 2. So H2SO4 will react with the magnesium hydroxide, it will give magnesium sulfate and also it will give water. So when acid reacts with the base, it will give their corresponding salt and also it will form water. So take one more example. You take one more example. Take any of the acid, HNO3 you take, right? You take any one of the base, sodium hydroxide or potassium hydroxide you take, right? What it will give? It will give potassium nitrate salt, that is KNO3, and also it will form H2O, right? So some more examples you can also try. You take HCl or acetic acid, you take weak acid also you can take, right? Or strong acid you can take. So I am taking here weak acid. When weak acid react with the strong base NaOH, what it will give? This will give CH3COO, Na, salt, sodium acetate salt, okay, and also they will form. It will give water, right? When weak acid, acetic acid is react with the strong base, it will give sodium acetate, which is in basic in nature. Why? Because we are using here strong base with weak acid. Okay, which one is the strongest in nature? Sodium hydroxide is strong. Base here strong. So we are getting basic nature of the salt here. The whatever you are getting the salt here during this reaction CH3CONA, we are getting a CH3CONA which is in basic in nature. Plus, and it will give water also, right? Like this you can write so many reaction. You take acid and base and also it will give the corresponding salts and water. So this reaction we call as a neutralization reaction. So neutralization reaction, when strong acid react with a strong base, it will give salt and water. And this type of reactions we called as salt. This type of reactions we called as neutralization reactions. During these neutralization reactions, we are getting salts. Okay, salt is now you see about salts. Come to the salts. Salt is obtained when hydrogen of acid is replaced by the metal. Then how we are getting this salt? Hydrogen of acids means acidic acid with hydrogen ions called as hydrogen of acids. When it is reacting with metals or sodium metal or zinc metal, anything, so what it will give? It will form sodium chloride and hydrogen gas. During neutralization reaction also we are getting these salts. Okay. Now we are going to discuss about the common salt. Common salt means, what is the common name of the salt? Sodium chloride. Common name of this salt is sodium chloride. Then how you are getting this sodium salt? Sodium chloride salt, how you are getting? From C. From C you are getting this common salt, right? Next one. Yeah. Now see, metallic oxides are basic oxides. Already we discussed. Metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. The basic in nature having the basic nature having metal oxides react with the acid, it will give salt and water, similar to the reaction of the neutralization reaction. Any acid when react with the base, it will give salt and water, right? Here metallic oxides are in basic in nature. This basic nature of metal oxides react with the acid and it will release salt and water. When base acid, the basic nature, acidic nature having substances, when these two reactants together they will react, so it will give salt and water. What it will give? Salt and water. Similarly, here also when non-metallic oxides are acidic in nature. When non-metallic oxide like carbon dioxide, sulfur dioxide, and sulfur dioxide, CO2, some more nitrogen dioxide also. Okay, NO2 also. Nitrogen dioxide, carbon dioxide, and sulfur dioxide. These all are acidic in nature. These all we called as non-metallic oxides. Okay, when non-metallic oxides are acidic in nature, when these acidic nature having salts, when this react with the bases, what it will give? Same thing, you will get same thing. What are the things you will get here? Here also you will get same thing. What are the get? It will give salt, water, and also, yeah, salt and water only. So metallic oxides when react with the base, it will give salt and water. When metallic oxide in non-metallic oxides, non-metallic oxides are basic in nature. Non-metallic oxides are in basic in nature. The basic nature having non-metallic oxides when reacting with the, sorry, cut it. Non-metallic oxides are in acidic in nature. Non-metallic oxides are in acidic in nature, right? The non-metallic oxides when react with the bases, it will give salt and water, similar to the reaction of the acid with the base. Okay. Now you see your pH scale. So what is the use of this pH scale? By seeing this pH value, we can say that if pH value is less than 7, so that solution is acidic in nature. If pH is equal to 7, that solution is in the neutral in nature. When pH value is greater than 7, above 7, that we can say that that is in basic solution. Okay, what is the range of this pH? 0 to 7 and 7 to 14. And 0 to 7, so 0 to 7, this we can call as acid. Wait here. Yes, 0 to 7, you take 0 to 7. So in this region, the medium is having in acidic in nature. In between 7 to 14, the medium is in basic in nature. Okay. At 7, it indicates neutral. Okay, it's at 7, that medium indicates neutral in nature. Okay, here pH scale, how, so what is the pH scale? Negative logarithm of concentration of H plus ions also we called as pH. Negative logarithm of concentration of H plus ions we called as pH. Or we can define, so by using this pH meter or pH scale, so we can easily assume that which one is the acid and which one is the base. The pH has a pH meter. pH meter, when you dip this pH meter in any acidic medium, it will give pH value less than 7. It will give pH less than 7. Okay, when you dip this pH meter in basic medium, okay, when you dip this pH in the basic medium, so you take basic medium and dip this pH meter. So this pH meter is connected to one display. The display shows the value of 7 or 14 or 8 or 9. What is the pH value, the solution we are taking? Okay, so when you dip this pH meter in the solution, and it will give pH value. So based on this pH value, you can came to know which one is the acidic in nature, which one is the basic nature. Suppose here we are taking the basic nature having medium. So in that we are keeping the pH meter. Suppose this basic nature having medium showing the pH value 9 means this is above 7. 9 means this is above 7. Above 7 indicates that the solution is in basic in nature. So in this display we can see that number 9. Okay. So 7 to 14 is basic. Okay, so in this region, medium is basic, and 0 to 7 in this region, medium is acidic, and at 7 the medium is neutral. The solution is neutral. So when we look at the acidic solution having the pH value less than 7, basic solution having the pH value greater than 7. Is it clear, everyone? Right? Now you see here, pH of salts, right? We have different types of salts: neutral salts, acidic salts, and basic salts. When we look at neutral salt, when strong acid is react with the strong base, it will give neutral salt. Okay, when strong acid is react with weak base, it will give pH value less than 7. That is in acidic in medium. So here, which one is strong? Acid is strong, base is weak. Okay, the resultant salt is acidic in medium, right? Now you in the third column you see here, so in this one, in this one, acid is weak, base is strong. Here which one is strong? Base is strong. What is the type of salt you are getting here? Basic in nature. When strong is base, when you take strong base, it will give basic salt. When you take strong acid, it will give acidic salt. The other one is weak. Other one is a weaker. Okay. When strong acid is added to the weak base, what it will give? It will give acidic salt. The pH of the salt, when you dissolve in this, the pH value, you will get less than 7. Right? When weak acid is reactive with strong base, what are the type of the salt you will get here? Basic salt you will get. What is the pH value of this salt? pH value is greater than 7. pH value is greater than 7. So remember all of you, when strong acid is react with the strong base, it will give neutral salt. Right? Is it clear, everyone? Right. Now, when strong acid is react with weak base, what is the type of salt you will get here? Acidic salt. What is the pH value? Less than 7. So when you will get the neutral salt, what is the pH value? Equal to 7. Right? Acidic salt pH value less than 7. When this salt, when you dissolve in the water, the pH value will become less than 7. It will show less than 7 pH value, acidic salts. When weak acid is reactive with a strong base, you will get basic salt. Here base is the strong, that's why you are getting the basic salt. In second column, acid is strong, weak, base is weak. That's why you are getting acidic salt, right? Here you see in third column, this one. Just a minute. Here you see here. Okay. Something. Okay. Now, so when weak base is added to the strong base, here which one is strong? Base is strong. That's why you are getting basic salt. pH value is greater than 7, right? When strong acid is reacted with a weak base, here which one is strong? Acid is strong. That's why we are getting here acidic salt, right? The value of pH value is lesser than 7, less than 7. The value of pH is less than 7. Is it clear, children? Right? Now, so we'll discuss some examples also. So what are the examples? So first one, when you take strong acid, you give any example for the strong acid? Yes, yeah, HCl, H2SO4. These are the strong acids. When these strong acids are reacting with the strong base like NaOH, KOH, calcium hydroxide, magnesium hydroxide, all these are the strong bases, right? It will give neutral salt. What is the NaCl? We are getting the salt. This is a common salt. When you dissolve in the water, it will give the pH value is equal to 7 plus water. We will get here water, right? So this is an example for strong acid when react with the strong base, it will give the neutral salt. Similarly, you take when strong acid, you take any strong acid, H2SO4 is a strong acid. You take weak base, ammonia hydroxide is a weak base, right? So this is the strong acid and ammonia hydroxide is weak base. When strong acid is added to the weak base, what is the type of salt you will get here? You will get here ammonia sulfate, NH4 taken twice. Why NH4 taken twice is so 4? Why NH4 taken twice is so 4? Why? Because here NH4 is having the valency 1 and sulfate valency is, what is the valence of the sulfate here? 2. SO4 is minus 2, H4 is a plus. So NH4 taken twice, SO4 1. Okay, by writing the formulas, please take care about these things, right? Ammonia sulfate plus, what will you get here? You will get here water, right? When H2SO4, this is a strong acid. When strong acid react with the weak base, what is the salt you will get here? Ammonia sulfate. What is the nature of salt we got here? Here which one is strong? Acid is strong. Here which one is strong? Acid is strong. So the nature of salt is acidic. Nature of the salt is acidic salt, right? Here we are getting acidic salt. When this salt, when you dissolve in the water, this will give you pH value is less than 7, means you are getting your acidic salt. Similarly, when weak base is added to strong base, weak acid is added to strong base. Tell one example for weak acid. Yes, weak acid example is CH3COOH, right? This is a weak acid, right? When this weak acid is react with strong base, you take strong base, NaOH. NaOH is the strong base. What is the salt you will get here? You will get here sodium acetate, CSaCONa plus water, right? So in this example, what is the nature of the base? Here we are nature of the base is strong. We are taking the strongest one, and acid is a weaker one. When weaker is added to stronger one, in the stronger nature is basic in nature. That's why we are getting basic salt here. Why? Because here acid is the weak, base is the strong. The resultant salt, what here you are getting here? Basic salt you are getting. When you dissolve this salt in the water, the pH value will get greater than 7. pH value greater than 7. So this is the basic salt. Right? Is it clear, children? When strong acid is added to the strong base, you will get the neutral salt. The pH value will give the 7. When strong acid is added to the weak base, you will get acidic salt. The pH value is less than 7. When weak acid is added to the strong base, you will get basic salt. The value of pH value is greater than 7. Is it clear, children? Right? Now, Yes. Now you see, next one, just a minute, children. Yes. First, we have to clear all these things. Now you see, pH in daily life, right? So where we are using this pH in daily life, where we are getting an acid rain, yeah, tooth decay and bee stings and acid produced by the stomach. So these are the things we can face in our daily life. So our body works within the pH range 7 to 7.8. Okay. And the acid rain has a pH of 5.6, which affects the aquatic animals. How you are getting the acidic rain? How you are getting the acid rain? When rain means rain, when rain is falling, so there is a pollution in our atmosphere, right? So what are the types of pollution you have in atmosphere? Carbon dioxide is there, sulfur dioxide is there. So these are the acidic oxides, right? Metallic, non-metallic oxides, in acidic in nature, right? When these non-metallic oxides react with the water, rainwater. It will, when it is react with the rainwater, the CO2 or SO2, when react with the rainwater, it will form carbonic acid or sulfuric acid or sulfurous acid. These are in acidic nature. When this acid rain, so this is why when this carbon dioxide and sulfur dioxide, if in atmosphere is the concentration of CO2 and SO2 is more, the concentration of CO2 and SO2 is more, and this CO2 and SO2 when react with the rainwater becomes acidic in nature. Why? Because due to formation of the acids. When these gases, CO2, SO2 gases, when react with the water, what will you get here? Carbonic acid you will get, and sulfuric acid also you will get. That means whatever the acid you are getting, it causes acidic to the rain, acidic behavior to the rain. So the rain, the rainwater will become acidic in nature. When this rainwater, when flows into the river, in aquatic life will be disturbed. It affects the aquatic life. It is dangerous to the aquatic life. So this is not suggestible. Acid rain is not suggestible. So to reduce this acidic nature of the rain, we have to control the pollution in the atmosphere. Right? Now, plant needs some specific range of the pH of soil. Soil, some of the soils in basic in nature, some of the soil in acidic nature, some of the soil in neutral nature. Some of the plants require basic medium. So to some of the soils in basic medium means some of the plants require acidic medium. Suppose you are planting the acidic medium having acidic nature required plants, you are planting the basic nature having soil means it will not grow. So what we have to do here, that soil we have to make it acidic. Why? Because this plant required acidic medium, right? This plant required acidic medium. So our soil is the basic medium, then it will not grow. To make this soil acidic medium, what we have to do, we have to add the acids to this. Then soil become acid, right? Then soil become acidic medium. So this plant also required acidic medium. Now this plant will grow easily. Now some of the soils are in acidic medium, but some of the plants require basic medium. So when basic medium requiring having plants, you are planting in soil having acidic medium, it will not grow. So to make this acidic medium of the soil to the basic medium, what we have to do, we have to add some of the bases to this, right? Like calcium oxide, calcium hydroxide. When you add to this soil will become base. Then only it will grow, right? Some of the plants require basic nature of the soil. Some of the plants require acidic nature of the soil. Some of the soil and some of the plants require neutral soil. Okay, to make the required soil, we have to add required substances. Suppose soil is the acidic, but we require basic means we have to add the bases to that. But soil is the acidic medium. Soil is the acidic medium, but the plant is required basic medium. So what we have to do? Soil is the acidic medium, plant required basic medium. So how to make this soil to basic medium? By adding basic substances like calcium oxide, calcium hydroxide. Then this soil will become basic in nature. Some of the plants require acidic medium. Suppose our soil is the neutral. Our soil is the neutral, but my plant required acidic medium. Then what I have to do here? What I have to do? I have to add acidic substances. What are the acidic substances? Can you give acidic salts also there now? Just now we studied acidic salts. What are the acidic salts we got here? Ammonia sulfate is there, right? Ammonia sulfate, it is in the acidic in nature. When you add that salt to the soil will become acidic in nature. When you plant the acidic requirement having the plant, you plant it in the soil, then it will grow easily. Okay, so before adding that one, so our soil is the neutral. Suppose our soil is the neutral, we require acidic medium. What we have to do? We are adding some acidic salts to this. Acidic salts. Now soil will become acidic. So when you plant acidic requirement having plants, now it will grow easily, right? So depends upon soil. So before planting the trees or before planting anything, you have to test the soil. How will you test the soil? You take soil in the glass, you take some of the water and dissolve the water in the soil. You filtrate that water, and this water you take in the lab. So lab, in our lab you see your pH meters are there, right? So you take pH meter, you dip in that solution. Then suppose the soil is having neutral, means which will show pH value 7. Suppose the soil is in acidic, means the pH value is less than 7. Suppose our soil is the basic, the pH value shows basic in nature, right? Like this way, so this plants need some specific range of the pH, right? Now, yeah, acids produced by stomach helps in the digestion. Yeah, so when you take the food, so it will go to the stomach, it has to be digested, right? So to digest that food, what we have to require? Our stomach releases some acids, HCl. So we are taking more food, you are taking excess amount of food. To digest that excess amount of food, our stomach has to be released more amount of acid, right? So if it is releases more excess amount of acid, we will get stomach pain, irritation, something we can get, right? So to reduce that stomach ache or stomach pain, to reduce acidic nature of our stomach, what we have to add in our stomach? We have to add basic nature having substances like milk of magnesia. Okay, the doctor we are suggesting by doctors syrups. The syrups consist milk of magnesium hydride. So when you take this milk of hydride, so two syrups or 1 5 ml, then it will go to your stomach, and the stomach, in the stomach acidic medium is there, you are giving basic medium. This basic and acid, what will get? It will react with each other, and the excess amount of acidic nature will be reduced. In this manner, we can get relief from stomach pain. Okay, now tooth decay. So when it will start to decay after taking meals, you are not washing properly your mouth. Then what will happen? Some of the particles are trapped in your teeth. These food particles react with the bacteria. This bacteria, when it is react with the food particle, it releases some acids. Okay, it causes tooth decay. Our enamel, this teeth, our enamel is made up of with hard substances, that is calcium phosphate. Right? This calcium phosphate, that when it is react with the acidic medium, it will get corroded. It will get corroded, right? Then your denser teeth dense will become decreases, reduce. The density of teeth will become reduced. That we called as tooth decay. Okay, tooth decay, when it will start? When you are not washing properly your mouth after meals, then overnight you are sleeping like that, then what will happen? Some bacteria will develop in your mouth. So whatever the bacteria is present in your mouth, that bacteria, when it is contact with the food particles, and they will combine and they releases some acidic medium, acid substances. Because of these acids, our tooth will become, what will happen in our tooth? Tooth decay will start, right? So when will you get this tooth decay? If pH value is lower than 5.5, in that time you will get tooth decay. So bacteria present in mouth produce acid by degradation of the sugar. Means you are taking some food. No, that food will react with the bacteria. It will degrade into acids. This acid will react with calcium phosphate. That hard enamel, it will, the coating of the hard enamel will reduce day by day like that. So that starts tooth decay. Okay, so when will you get this tooth decay? If pH of our mouth is lower than 5.5, in that time you will get this tooth decay, right? Now bee stings, okay. So bee stings produce acids which cause pain and irritation. When red ants, when you sting in your skin, what will happen? Some irritation will develop due to these red ants. What it will do? It will inject in your skin formic acid. What is that? Formic acid injected by red ants. That formic acid is the acid. When acid is induced to your skin, introduced in your skin, then skin will get pain, irritation, right? So bee stings also same. When bee sting stings in your skin, it also releases acids too in your skin. Okay. When you add then acid contact with our skin, what will happen? It causes some pain and irritation, right? So these are the things happens in our daily life, right? Next one, move on to the next one. Before that, we have to clean this board, right? Now, move on to this next slide. Yeah, preparation of sodium hydroxide. How will you prepare the sodium hydroxide? Yes, we are having the common salt. So you take common salt. To this salt, what we have to add, we have to add water. So we are taking the aqueous solution of the sodium chloride, brine solution you are taking, right? So brine solution we are taking. So when you add aqueous solution of the sodium chloride solution to this aqueous solution of the sodium chloride we call it as the brine solution, right? Brine solution, that is NaCl solution, right? NaCl solution. Brine solution we call it as NaCl. NaCl, you are becoming, this is aqueous NaCl, so you are adding the water. Okay, then when you add to the water, this salt dissociated into Na plus and Cl minus, and water is having ions H plus and OH minus ions. When you when you electrolysis this substance, you are taking one beaker. Okay, you are putting your salt solution. Okay, salt solution. What we are doing? We are keeping two rods here. We are keeping two rods, two graphite rods. We are keeping here two rods. Wait, just a minute. So here we are keeping two rods. This is two electrodes. Okay. Then what will happen after passing the current? This you connect to battery positive terminal, and wait, just a minute. This you connect to battery positive terminal, and this you connect to battery negative terminal. Negative terminal. So when you switch on the battery, what will happen? The current is passes through this rod. Okay, the current will passes through this solution, and this solution having which ions? Na plus ions and H plus ions. These are the positive ions. These positive ions are attracted by the negative electrode, and this negative electrode and this surrounding area is surrounded with Na plus and H plus ions, right? So in Na plus H plus ions, so which one is the lowest discharge potential? That one will get discharged. So here H plus is having the lowest discharge potential. This H plus discharged into the hydrogen gas. So here at negative electrode, some of the bubbles we can observe. So this bubbles is due to formation of the hydrogen gas. But this Na plus remains in the solution only, right? Okay. Here, now you take negative ions. What are the negative ions we have here? NaCl consists negative ions means Cl minus OH minus ions. These negative ions are attracted by the positive electrodes, and these negative ions are surrounded by this positive electrode. Okay, are positive electrodes surrounded by these negative ions. Okay, so this negative ions chloride OH minus is there. So this chloride is having the less discharge potential. So here we will get chlorine gas here. At positive electrode we are getting here. So some bubbles we can observe here. So this is due to formation of the chlorine gas. This OH will remains in the solution. Okay. Now the solution is having Na plus and OH minus. These Na plus and OH minus ions will combine and form a NaOH. Right. So in this way we are getting three things. When you electrolyte Now, when you electrolysis the sodium chloride in presence of water, what are the things you are getting here? At negative electrode, we are getting the hydrogen gas, right? At negative electrode, we are getting the hydrogen gas. Hydrogens are the cations. Cations are deposited at the cathode as a hydrogen gas. Okay. At cathode, there is a release of the hydrogen gas is taking place. So this is cathode, right? This negative electrode we called as the cathode, and this positive electrode we called as the anode. At negative electrode, here we can observe some of the hydrogen gas bubbles. Due to some reaction here, hydrogen gas is evolved, right? And when you take this chlorine gas bubble, where it will evolve? This is evolved at anode. Why? Because chloride is anion. Anions will go to the anode, right? So at anode, what will happen? This Cl minus ions will convert into chlorine gas. Okay. At positive electrodes, we can observe some bubbles, air bubbles, due to formation of the chlorine gas. At negative electrode, we can observe some hydrogen bubbles. This is the formation of due to hydrogen gas. Okay. So the solution in solution, the remaining ions is having Na plus and OH minus ions. Okay, and solution is consist Na plus OH minus. The OH minus ions remains in the solution. Similarly, Na plus ions also remains in the solution. When these Na plus and OH minus ions combined, it will give NaOH solution. So in this way, by using common salt, so you see, by using this small salt, common salt, daily we are using this. By using this common salt, we are adding some water, we are making salt solution. When you electrolyte this, when you electrolysis this, electrolysis means you are passing the electricity, you are dividing the substances. Lysis, electro means you are passing the electricity through the solution, NaCl solution. After passing the electrolysis through the solution, what is happening here? Anions are going to the anode side and cations are going to the cathode side. What are the anions we have here? Cl minus OH minus are the anions. Anions are the negative charge. These negative ions are attracted by the positive electrode. Similarly, cations, Na plus and H plus ions are the cations. These cations are attracted by the negative electrode. So cations are attracted by cathode, anions are attracted by the anode. Okay, so in the cation, sodium plus ions are there, H plus ions are there. So in that, which one is the lowest? Which one is having the lowest discharge potential? H plus is having the lowest discharge potential. So that will reduce its charge fast. Okay, then H plus reduced discharge, or H plus that is a charged ion, no? So it will form as a hydrogen gas. So at electrodes, what is happening? Discharge of ions are taking place. Okay, which one is lowest discharge potential? That one will discharge first, right? So here H plus ions evolved as a hydrogen gas at cathode. Okay, hydrogen gas is released at cathode finally, and Cl2 gas released at the anode. Cl2 gas released at the anode. Okay, then Na plus also Na plus remains in the solution. Similarly here OH minus ions remains in the solution. In the solution we are having now Na plus ions and OH minus ions. This Na plus OH minus will combine and it will give NaOH solution. Is it clear, children? Is it clear, everyone? Is it clear? Yes. Okay. Move on to the next one. Yeah, this is here we have one reaction. Here sodium chloride is there, right? When sodium chloride react with the water, so on what we are doing, we are passing the electricity. We are lysis the substances. Lysis means we are dividing by passing the electricity. What are the substances you will get after electrolysis of the sodium chloride salt? You will get your sodium hydroxide aqueous solution, chlorine gas, and hydrogen gas. Now hydrogen gas released at the cathode, chlorine gas released at the anode, and solution. In the solution you will get sodium hydroxide aqueous meaning sodium hydroxide formed in the beaker. Okay, at positive electrode you will get chlorine gas. Positive electrode we called as the anode. At anode you will get chlorine gas. At negative electrode is the cathode. At cathode you will get hydrogen gas. So in this way, by doing simple electrolysis of NaCl solution, we will get three main products. Those are hydrogen gas, chlorine gas, and NaOH. Now you see what are the uses of this? So hydrogen we can use in the fuel as margarine, right? Wait a minute. Ammonia for the fertilizers. So to prepare ammonia also we can use this hydrogen gas to prepare ammonia. Okay, ammonia we are using in fertilizers. Now you see what is the use of the chlorine gas to treatment water to kill the microorganisms which are present in the water. So we can use this chlorine gas, and in swimming pools also. Okay, to remove microorganism in swimming pools also we are chlorinating the water. So to make the PVC pipes, polyvinyl chloride pipes, have you seen these pipes? Big longer tube pipes. Okay, we are using in the mission Bhagiratha in Telangana government, right? Polyvinyl chloride we are using, the polyvinyl chloride pipes we are using in our household also. Some of the in kitchen you take, or in your washroom. So some of the polyvinyl chloride we can observe, right? Polyvinyl chloride pipes, these are the made up of with chlorine. And also chlorine mainly used as disinfectant, that's why we are using it for water treatment. And also to prepare chlorofluorocarbons are used as a refrigerant. So to make the chlorofluorocarbons we are using the chlorine gas, or also to make the pesticides we are using this chlorine gas. Okay, these are the uses of the chlorine gas. See, by doing simple electrolysis of the common salt, whatever we are using for in daily cook, okay, daily use aluminum, in daily use we are using the sodium chloride salt, right? The sodium chloride, but while doing the sodium chloride, when you're doing this electrolysis, when electrolysis is done in the sodium chloride solution, what are the useful products you are getting? Usage hydrogen gas you are getting, chlorine gas you are getting, and NaOH solution also you are getting, right? So what is the main uses of the NaOH? NaOH means this NaOH we can use it as degreasing the metals, right? So sodium hydroxide and the soapy in touch, right? Because of this soapy in touch, we can use in the degreasing the metals to make the metal surface soft. We are using this sodium hydroxide, and also to prepare soaps and detergents, we are using the sodium hydroxide, and to for paper making industries. Okay, here we have BPL industries, the paper making industries. They are using the sodium hydroxide to make the paper. Okay, to make the artificial fiber also sodium hydroxide is used. So it has so many uses. Okay, some of the important uses here they are listed out here. Next, when these hydrogen and chlorine combine, what it will give? It will give acid. That is what hydrochloric acid also we are forming by doing simple electrolysis of the common salt. So we are getting this many products. You see how many products we are getting, this many products we are you getting, right? This many products you are getting. So one is hydrogen gas, one is hydrogen gas you are getting, right? So hydrogen gas you are getting, next to chlorine gas, next sodium hydroxide, next hydrochloric acid, next bleach. Yeah. How will you get this hydrochloric acid? Here you are getting hydrogen gas, you are getting chlorine gas. When you combine these hydrogen and chlorine, it will give HCl, right? So this HCl is used for the cleaning steel, and to prepare ammonium chloride, and to prepare some medicines and cosmetics. For preparation of the cosmetics and medicines, we are using this hydrochloric acid. These are the some of the uses. So it has many uses. Next, bleaching. How will you prepare this bleach? Bleach means, so to clean our house daily. Your mother is cleaning your house by pouring some phenol or some bleaching agents in water. Okay, that's bleaching. Some bleaching powder. So it has to bleach. Bleach means to clean the household. We are using this bleach. Okay, bleach is a combination of NaOH and chlorine. Okay, NaOH and chlorine will give the bleach action. Bleach means it clean the floor. How it will clean the floor? By removing bacteria, microorganism. It kill the chlorine is there. No, chlorine means chlorine. What is the main use of the chlorine? It can used as a disinfectant, right? So this bleach we can use in the household bleach, bleaching fabrics. Okay, so these are the some uses of the bleaching agent. Now, yeah, bleaching powder is there. The white color powder. Already you know this. Already you have seen, I think, right? So bleaching powder. What is the main formula of the bleaching powder? That is calcium oxychloride. What is the formula of the bleaching powder? Bleaching powder, calcium oxychloride. Calcium CaOCl2, right? CaOCl2. Calcium oxychloride, right? Calcium oxychloride, CaOCl2. Then how will you get this calcium hydroxide? When chlorine gas, when you pass to this calcium hydroxide solution, then we will get calcium oxychloride plus water. Then what are the uses of this bleaching powder? To bleach the cotton and linen in textile industries, to remove the colors. Okay, we are adding this bleaching. And also so we are bleaching the wood pulp in the paper industries to remove the impurities from the paper, to remove the colors from the paper. Wood to In paper industries we are using for paper making we are using wood, right? Okay, so to remove this color of the wood, to remove impurities from the wood pulp, we are adding the bleaching powder, right? To wash the cloths also we are using this bleaching powder. Okay, next oxidizing agent. It also used as oxidizing agent. Oxidizing agent means it oxidizes other substances. Used as oxidizing agent in chemical industries, and also we can use it as disinfectant. Okay, so in corona time we are using this powder, right? So to remove the coronavirus, and also this we can mixed in the water also, right? So in our municipal peoples are doing what they are doing. They are adding some bleaching powder to the water and they are supplying to the houses, right? So used for disinfecting drinking water. Okay, to remove the disinfectants from the water we are using this calcium chloride, right? Now you see here, next one, baking soda preparation. So this is baking soda means daily we are using. So in every house we have this, right? That is in white color powder. To making pakoras, bhajis, we are using this powder, right? So what are the main uses of this baking soda? How will you get this baking soda? The sodium bicarbonate is the baking soda, right? So this is used as an antacid. This is used as antacid. So this is a weak basic in nature. Okay, when red and sting in your skin, so you will get some irritation. You take some baking powder and you rub it, the irritation will come down. It will get reduced, right? So as it is an alkaline, so it is a soluble in water, so it has having alkaline in nature, and also it neutralizes excess acid in stomach. In eno powder also, so sodium bicarbonate they will use, right? In eno, to reduce the stomach pain and acidity nature in the stomach, to reduce the acidic nature in the stomach. So when you take this baking soda, some of the pain it will get relief. So we'll get relief. How will you get relief? This is an alkaline medium. When alkaline medium acts with the acidic medium, what will happen? It will form neutrals. It will give neutral salt, right? In this way the acidic medium will be reduced to neutral medium, right? So and also it is used in the soda acid fire extinguishers. Why we are using fire extinguishers? Here CO2 gas is there. CO2 gas is used for the fire extinguisher, right? In sodium bicarbonate, when you sprinkle on fire, the fire will get extinguished, means the fire will get disappear immediately. Why? Because so in that sodium bicarbonate, so we have when sodium bicarbonate, when you heat, so when you are adding to the flame, what will happen? So it will take some heat from that and it releases some CO2 gas. The CO2 gas will clear all the fire, right? So and also used as the fire extinguisher. CO2 is also used as a fire extinguisher, right? Soda acid also we can use as a fire extinguisher. This powder we can, when you sprinkle on the flame will get disappear immediately within 2 seconds. That means this is also used as fire extinguisher. For making baking powder, so what is the baking powder? Where we use this baking powder? To prepare the cakes. To prepare the cakes, to make the cake spongy and soft, we are using this baking powder, right? For making baking powder, mixture of baking soda and mild acid, tartaric acid. So how we are preparing baking soda is different, baking powder is different. Baking soda is only sodium bicarbonate, right? Baking soda is sodium bicarbonate only. baking powder is it is a mixture of baking soda and tartaric acid. Okay, baking soda and tartaric acid. So this will give you the baking powder. Where we use this baking powder? In cakes, to prepare cakes, to make the cakes fluffy, soft and spongy. we are using this baking powder, right? So when you heat, suppose this is the baking soda, sodium bicarbonate, you are adding the acid consists of H plus ions, then what it will give? It release CO2 gas, H2O and sodium salt of acid. The gas whichever produced in baking powder, CO2 gas produced in this reaction, okay, this CO2, when it is released from the case, then it will give some pores on the case. It will form some pores on the case. Okay, in the place of CO2, CO2 will come up, right? When you heat this cake, when you suppose you are taking to making dough, right? What we are using, we are taking some maida powder, right? You are adding some salt, or you are adding some baking powder. You are making one dough, right? So you are keeping in the oven. Then what will happen after keeping the oven? So because of heat, what will happen? This CO2 trapped in the dough, it will get escaped from that. So in that place, some pores will form. Due to that pores, the cake will make fluffy, soft, and spongy. So in this manner, we are using this baking powder to make the cakes fluffy, soft, and spongy. We have to use this baking powder. If you forget to add this, your cake will become very hard. That is not a cake. That is hard substance. It will become hard substance. Okay. To make spongy, soft, fluffy, we have to add this baking powder. Right. Now you see washing soda preparation. How will you prepare the washing soda? So very important. Nothing is there. Sodium bicarbonate is there. When you heat the sodium bicarbonate, so baking soda will become washing soda. Just you are heating this. Whatever you are doing here, you are taking the baking soda. Just you are giving heat. You are taking one container. In that container, you are adding some sodium bicarbonate salt. You are heating. Then what will happen? It will when it is absorb the heat, so it has some CO2 gas. CO3 is there, no? This CO2 is escaped as the CO2 gas. Okay, and the sodium bicarbonate, 2 moles of the sodium bicarbonate formed as sodium carbonate and water. So evolution of the water also takes place, and CO2 gas also released. When this sodium carbonate, when it is react with the 10 moles of the water, when you add this after preparing from this sodium bicarbonate, you are heating, no? So from this you are getting sodium carbonate. Okay, this sodium carbonate, you keep it for some time in an atmosphere. Then what will happen? This sodium carbonate will absorb the water molecules from the atmosphere. How many water molecules it will absorb? 10 moles of the water molecule it will absorb and form as sodium carbonate 10H2O. So this 10H2O is the water of crystallization. Okay, this Na2CO3 dot 10H2O is a formula for the washing soda. What is the formula for the baking soda? NaHCO3 is called as baking soda. How will you prepare the baking powder? We are adding sodium bicarbonate to tartaric acid, then it will give baking powder. Okay, what are the main uses of this washing soda? What are the main uses of this washing soda? What are the main uses of washing soda? So this washing soda we can use for making glass, to make the glass. So glass is a combination of the sodium silicates, Na2SiO3, right? Here is the Na is there, silicate from the sand we are taking, silicas. Where will you get silicas? From sand. Okay, when you add this sand to washing soda, it will give glass. So to make the glass and to prepare soap and water, so manufacture water. So how you are using water? So to remove the temporary hardness from the water, we are adding washing soda. Okay, temporary hardness from the hardness of the water, to remove hardness of the water. Water hardness is due to salts of calcium, magnesium, chloride, sulfate salts, right? Calcium chloride, magnesium sulfate, calcium carbonate, magnesium carbonate. Okay, due to these salts, water contains some hardness. To remove the hardness from the water, we are adding this washing soda, right? To manufacture of sodium compounds such as borax powder, right? Where will you use this borax powder? Yes, where will you use this borax powder? Yes, right. Uh, so for carom board, to sprinkle on carom board, this powder we can use, right? Next, to cleansing agent also we can use as cleansing agent, domestic cleansing agent also we can use this, right? And to remove permanent hardness of the water, we can use this. Okay, these are the main uses of the washing soda. So water of crystallization means what? Here we listen one term, so water of crystallization. So fixed number of water molecules is present in one formula of a salt we called as water of crystallization. So CuSO4 dot 5H2. The CuSO4 salt is combined with the 5 water molecules. So that means that blue crystals of copper sulfate consist 5 water molecules. When you heat this, the crystal nature of the salt will lose, right? It will become white powder only. The face powder is very smooth, no? Like that powder we will get when you heat the copper sulfate 5H2O, right? Salt. When you touch the salt, it will give you some crystal nature, right? It gives you some crystal nature. When you touch the sand touch is like crystals touch, right? So here also copper sulfate 5H2O is like our salt, copper sulfate with 5H2O. When it is combined with the 5H2O, and it will form as crystal, right? That will give the blue crystal of copper sulfate we can see here. When this blue crystal of the copper sulfate, when you heat, what will happen? The 5 water molecules will lose as a vapors. Then the remaining powder will become white powder. The blue will become white powder, right? The white powder is in soft in nature. Then this white powder, when you keep it for some time in atmosphere, so it will absorb water molecules from the atmosphere, and it will form as again copper sulfate 10H2O. Again we will get here blue crystals, we will get here CuSO4 dot 10H2O or 5H2O. So this we called as a water of crystallization. Okay. Now plaster of Paris. It's a hard substances to make statues, to make Vinayakas, to make Ganesh Vigraha. We are using this plaster of Paris. What is the formula of the plaster of Paris? Calcium sulfate of H2O. Calcium sulfate hemihydrate, we call it as plaster of Paris. How you are getting this calcium? How you are getting this plaster of Paris? By heating gypsum. Gypsum means, what is the formula of the gypsum? Calcium sulfate dot 2H2O is the formula of the gypsum. This calcium sulfate dot 2H2O, when you heat in 373 Kelvin, it loses one and a half water molecules from this. From two water molecules, it loses one and a half water molecule, and this calcium sulfate dot half of the water molecule give you POP. Okay. To finishing our walls also we are using this POP. To to making smooth walls, to prepare smooth walls, we are using this POPs or plaster of Paris. What are the main uses of this plaster of Paris? So plaster of Paris main uses for the to plastering the fractured bones. When bones get fractured, you will get some white color strip, right? That is made up with the plaster of Paris. And also POP on mixing with the water turns into the gypsum. When you add some water molecules to this, it will become hard substance. That means that is gypsum. Gypsum, when you cement, you know the cement powder, right? That is cement powder. When you add water, what will happen? It will become some hard substance. It will give hardness, right? Similarly, here also same thing happen. When you add POP to the water, so it will form hard solid mass. Means it will convert it into gypsum. So and also this POP we used for making toys and decoration materials to make rough surface smooth. We are using this POP materials, right? Is it clear, everyone?
So this is your acid base lesson. Thank you for watching.